This video, we're going to take a look at how to name and draw alkynes. Alkynes are also aliphatic hydrocarbons, except instead of having a double bond or single bond, they contain a carbon-carbon triple bond, at least one. And like alkenes, they're also unsaturated. Their general formula is CnH2n minus 2. Remember, alkanes had CnH2n plus 2. An alkene had CnH2n, and an alkyne has 2 hydrogens less. So for example, if I had an alkane that was a chain, so I'm talking about straight chain here, not the cyclic. Cyclic is -4, so even 2 less than the chain. If I had an alkane that was linear with 8 carbons, it would be C8H18. The alkene would be C8H16, and the alkyne would be C8H, so times 2 minus 2, 14. And that's because you have another bond added where you didn't have it before, and it takes away 2 more H's compared to the comparable alkene. So how do we name alkynes? Essentially the same rules as alkenes. The main difference, though, is that the ending has to be an YNE instead of ENE, and that's about it. So let's go take a look at an example here. We have a molecule given to us. We have to figure out its name. So we're going to count in a way that prioritizes the triple bond having a smaller number, which means we're going to go from right to left. 1, 2, 3, 4, 5, 6. Okay. And so we have 5-methyl, and then hex-2-ine, But-1-ine. That means there's 4 carbons. And we're going to put a triple bond at carbon number 1. We'll add an H here because this needs 1 more bond. This carbon does not need another bond because it already has 4. This one needs 2. And this one needs its 3. Now I'm going to show you how to do this for the line diagram. The line diagram you have to be careful with for alkynes. Alkynes make a linear shape, so it really makes that chain more straight than zigzagged. So when you're doing that, what you do is you would have carbon here, and the way you do it is you put your 3 lines like this. So this is your first carbon, this is your second, and you can't zigzag the other one. The other carbon now has to continue here. So this would be your third over here, and then you can zigzag down. So it's a bit trickier. You got to be careful. So you have carbon here, like this and this. Then this one is still part of that little straight chain line because of the triple bond. So right here, and then you can start zigzagging again. So essentially the carbons directly next to the carbons of the triple bond, they're still part of that straight chain. And you can't zigzag until you're beyond those. So that would be our but-1-ine. Let's try 5-methyl hex-2-ine. So hex means there are 6 carbons. 4, 5, 6. It's at carbon number 2, so 1, 2, 1, 2, 3. And the methyl is at carbon number 5, so 1, 2, 3, 4, 5, 6. And then we can put our H3 here. Nothing needed there, nothing there. H2, H, and then H3. You can also do the same thing, but for a bond line diagram, and I'm going to show you how that works again, because you have to have that straight chain, at least for the carbons next to your triple bond. So let's go ahead and do that. So our first, what I usually do is I usually like to draw the triple bond first. Keep in mind this is carbon number 2, so I'll make carbon number 1 right here, and then carbon number 3 right there. And then you can start zigzagging again. So we have 1, 2, 3. Sorry, I should have said carbon number 4 right there. So 1, 2, 3, 4, and then 5, 6. And so on carbon number 5, we had a methyl. So 1, 2, 3, 4, 5. There we go. And there's our methyl. Okay. Don't get too bogged down by this. If you make a zigzag, it is something that you have to pay attention to because it goes against the structure. But if this is going to stop you from drawing, then just make the zigzag and you'll get some feedback about doing this on an assessment. Make sure it's drawn linearly. But again, don't let this boggle you down too much. If you don't like this, you can just draw the triple bond version using the expanded or condensed expanded formula, condensed molecular formula, structural formula. Choose something that makes you feel less anxious when you're doing it. It's good to get practice doing both, though. All right, so let's try the one over here where we have 7 carbons and 2 triple bonds. So it's a heptadiene. So 1, 2, 3, 4, 5, 6, 7. It's a carbon number 1 and carbon number 3. Now we can go put in our H's. There's our hepta 1,3-diene. And so this one's an interesting one to draw. You could even do it. You don't have to be angled like this every time. You could even start like this. So you can do. So this is carbon number 1 here. And then 2. So 1, 2, and then continue to carbon number 3. The carbon number 3 also has a triple bond. So it's carbon number 4 here. So then we have carbon number 5 coming about here. And then you can start sort of zigzagging again. So 6, 7. So 1, 2, 3, 4, 5, 6, 7. And that would be our hepta 1,3-diene. All right, here's another one to try out. We have multiple triple bonds here. Our goal is to find the longest parent chain that contains those triple bonds. So that would be this over here. Now we have to start numbering in a certain direction. Notice that we have a tie. We can either start numbering here or here. But if you continue going, the next spot where there's a triple bond is over here. So 2, 3. So 4, 5, 6, 7, 8, 9. So that means that from right to left is a better option to do. Let's go ahead and list our substituents. So at carbon number 7, we have chloro. I'm listing them alphabetical order here. So 7 chloro. And then 1, 2, 3, 4, 5 methyl. And there's 9 carbons, so it's a nona. And then the triple bonds are at carbon number 1, 3, and 8. 1, 3, 8, tri-ine. And that would be your name for this molecule here. So in this video, we saw some examples of naming alkynes, very similar to examples where we would name alkenes. The only difference is that we have the YNE instead of the ENE. Just as a final note, sometimes you could have triple bonds and double bonds together. We'll see that in another lesson later on, but if you do see that, you're more than welcome to try it out as a challenge and see if you can figure out the answer once you check out the steps and answers provided and see if you learn anything from the feedback there. For now, we'll keep it primarily just double or just triple or just single. And that there concludes the aliphatic hydrocarbons, alkanes, alkenes, and alkynes. In the next video, we're going to just take a quick look at the properties of hydrocarbons, which we already know since we saw that in the first unit.